Hello everyone. A request was made to explain in detail how it was that we manipulated the interpolation coming in and leaving a keyframe point on our composition, Now, what I'm going to do for this exercise is I am going to have a basketball graphic that is going to come in from the left-hand side of the screen, bounce in the center of the screen at the bottom, and then bounce off the screen on the right-hand side. So let's start by creating a composition. I'm going to make it 1280 by 720. I'm going to change my frame rate from 25 to 30 FPS non-drop frame, and I'm going to keep this to about 4 seconds. So I'll click OK. And then what I'm going to do is I am going to bring in that graphic that I have prepared for this exercise. Now, what I mentioned a second ago is the basketball will come in from the left-hand side of the screen. It will come on a curve, slowly start speeding up, and as it speeds up, it hits the ground. It will bounce fast again and start slowing down as it goes to the other side. That's what physically would happen in the real world. So now we're not trying to go for exact physics here, but we're trying to manipulate the graphics so that they look less computer generated. So to do so, I calculate that this bounce will probably take about 1 second. So I'm going to give this about 15 frames to hit the bottom of the screen and then another 15 frames to go off the screen. And to do that, we're going to be changing position keyframes and probably rotation keyframes as well. So now to do so, I will go ahead and set up a first keyframe, a position keyframe for this graphic on at the 0 point mark. Then I'll go down to my 15 frame mark and I'll set up a keyframe for it down at the bottom of the screen. And then I'll go to the 1 second mark and move it to the opposite end of the screen, to the right hand side. Now, you'll notice that my motion path turned into a curve right away. This indicates to me that the spatial interpolation for this particular graphic is set to Bezier. That happens with the program. In class, we've been seeing that it gives us straight lines, and that means that interpolation is linear. Now, we can take advantage of this and start working with this as is, or we can go ahead and start from scratch the way we did it, the way we saw in class, which is by, if I go to my middle point, you'll notice that I have the Bezier handles. If you don't have the Bezier handles in your middle keyframe, I would suggest you right-click, go to keyframe interpolation, and change your spatial interpolation from linear, which would be what you see here, the straight lines, to Bezier or Auto Bezier. Now, Auto Bezier will give you the handles that control both sides of the curve. Bezier will give you separate handles that act independently. So if I go back into that and change from continuous Bezier, to Bezier, then I'll have the ability to manipulate each handle separately. And as you can see, now I am getting the path in the shape that I actually intended to be, which is for the ball to sort of create a curve coming down and then create another curve as it bounces off. Then you'll notice that for these keyframes, I also have a Bezier handle. When I select them, it becomes active, and then I can fine-tune my motion path, sorry. So with that done, then I have pretty much the trajectory of the motion path that I want. Let me bring in my work area endpoint to the 1 second mark, and I will go ahead and preview this. And as you can see, it's a very mechanical motion, and that's because although my spatial interpolation is now Bezier, meaning I actually have a curve, I still have equidistant rate of change between the keyframes. And if you see the distance between my frames, it's pretty much the same, which means my motion will be completely linear. To affect that, to change that, to make sure that this slows down and starts accelerating as it goes down, and then it decelerates as it goes up, I will have to change the way these keyframes talk to each other. To do so, I will select the keyframes, and I will open up my graph editor by clicking on the little icon over here in the switches area. Now let me go ahead and expand this slightly, and you can see now that this is the path that indicates the rate of change for my graphic. If I select these keyframes here and I don't see handles the way I see them right now, remember to switch from you probably are in your value graph. So switch from your value graph, which is what this looks like, to your speed graph, which allows you to handle the position of the keyframes. Now with that done, let me undo that really quick. I'm going to select each one at a time, and you'll notice that let's start with the middle. So for this one, you'll see that I have my incoming interpolation into that keyframe and my outgoing interpolation. As I did in class, the fastest way to manipulate this is to consider that you have a chart that is talking about time, which is your timeline on the x-axis here, down here, versus the rate of change. How much am I changing? How many pixels per second am I moving? That is what this graph indicates. So the lower the graph goes, or the higher it goes, the more the rate of change in between those tween frames. So the goal was to create something that allowed me to get this closer at the top and further apart at the bottom. And that is because the closer the tween frames are, they're basically, you're giving them the exact same amount of time to travel a shorter distance. Therefore, they will be moving slower. And so let me get my graph to look like this. Might be a bit too much. And then I'm gonna, now that you see that these are closer on this end than they are down here, I'm gonna try to duplicate that on this side. So I will be moving this down to the 0 mark. I will be expanding my graph in this direction. And perhaps match the position of this one. Okay, so let's try that graph. That starts very slow and it speeds up as it goes down. So that gives you a bit of a more natural bounce. Now the exercise now becomes to fine-tune this to a point where you have more of a natural motion mimicking that of real world physics. Sorry. And then you can go ahead and fine-tune. To sell the effect a little bit better, I would suggest also activating your motion blur switch. And that's still a little bit iffy. I don't like the way that it sort of stops at the bottom. I need to make sure that this actually bounces better, so that it spends less time at the bottom, perhaps. That's better, even though it's a bit fast. So that seems to be now an issue with the timing overall. It seems like I didn't give enough time for this action to happen. And so that means I would have to expand my keyframes. And I haven't shown you how to do this in class. I will probably show you, but if you select all of the keyframes and you press the Alt key on the keyboard and drag the last of the keyframes that you've selected, you will be expanding them proportionally so that they remain equidistant based on the distance they originally were placed on. And so I'm giving a little bit more time to my animation and it looks a little bit smoother. So that is how you access the interpolation controls for manipulating the keyframe at rate of change to make sure that you actually fine-tune the animation.